Hello there. In this video, I'm going to be showing you an alternative way to show that cos theta minus phi is cos theta cos phi plus sine theta sine phi. This method can be found in the book Fundamentals of University Mathematics, 2nd edition, by Colin McGregor, Jonathan Nemo, and Wilson Stothers. And you'll find this on pages 109 to 110. Okay, so I've redrawn these diagrams here to share it with you, but if you are interested in a similar proof, just check out that book. So to come up with this other proof, we need to know the distance formula in 2 dimensions. Okay, so if you know that, we're going to be able to come up with this proof. I'm not going to share it in this video because I have shared it in other videos, but I could leave a link to the bottom of this video on how to derive the distance formula in 2 dimensions. So if you're interested in that, just click the link below this video and it will take you to that proof. But let's get back to this proof over here. So we're going to need 2 diagrams for this proof. That is figure 1 and figure 2. Both these triangles are isosceles triangles. They both have sides of 1 and they have a central angle of theta minus phi. Now, why are these central angles theta minus phi? Well, it's because the point P consists of cos theta sine theta, okay? So the angle from 0 to this theta is simply theta. Now Q has the coordinates cos phi sine phi. So from 0 to phi, you have the angle phi. Now if we go all the way to theta, okay, but we're subtracting phi from it, we're left with theta minus phi. Okay, so this angle over here at the center of this isosceles triangle is theta minus phi. Now we have a similar situation over here. The angle all the way up to A is theta minus phi, and B, okay, has the coordinate 0 for y. So we're starting at the origin here, and we produce the angle theta minus phi. Now, I would recommend having a look at these images carefully before proceeding with the rest of this video. Okay, so we've identified that these triangles over here are the same. And because they are the same, the distance from P to Q is going to be the same as the distance from A to B, okay? And if we make them both equivalent, these 2 distances, what we could do is end up proving that cos theta minus phi is cos theta cos phi plus sine theta sine phi. Okay, so we are going to do that next. Okay, so I've made a slight change to the workings that I had before. I've put a 0 over here instead of a 1. Okay, so I've made that change. Now, the distance between P and Q is going to be the square root of cos theta minus cos phi squared plus sine theta minus sine phi squared. Okay, so we're using the distance formula to get this. And similarly, okay, the distance from A to B is going to be the square root of cos theta minus phi minus 1 squared plus sine theta minus phi minus 0 squared. Okay, this change over here is very important because this 0 here can't be equal to 1. The coordinate B has the point 1, 0. Okay. Okay, so what we do next is we make the distances from P to Q and A to B the same as each other. And if we do that, we can end up with an equation where we can get rid of the square root symbol on both sides. If we do that, we can simplify to this over here. But because cos alpha squared plus sine alpha squared is equal to 1, we can remove these unnecessary parts, okay? And we end up simplifying to this, and then this, and if we continue, we get our identity, okay? Cos theta minus phi is equal to cos theta cos phi plus sine theta sine phi. And there we have our proof. So you can check the workings over here in your spare time. Okay, so that's our proof. If you have any questions, leave them in the comment section and I'll get back to you as soon as I can. For more mathematics proofs, check out the book Fundamentals of University Mathematics, 2nd edition, by Colin McGregor, Jonathan Nemo, and Wilson Stothers. Okay, this proof was found on pages 109 to 110. So check out that book and I'll leave a link to it just below this video. For more maths content, be sure to check out mathematics.proofs on Instagram. Thanks for watching this video and see you next time.